Hi everyone, Mr. Lansing here, and in our short video today, I will be teaching you on how to find the zeros of quadratic functions using the square root method. So our main objective or main target for today is to help you understand the process of solving quadratic functions using this new method called the square root method. Just to give us a short recall, we have covered the following methods in solving quadratics since we started doing it a few days ago. So we know how to graph using decimals or using our TI-84. We can also factor as a method in solving or finding zeros. We use the quadratic formula. Yesterday during async, you had completing the square, and then today for another async day, we'll be doing this. Before giving you a few examples, let me just remind you that this square root method is quite limited in terms of applications because this is not applicable to all types of quadratic functions. This is only applicable when the quadratic function looks like this: f of x equals ax squared plus c, where the linear term bx is missing. So if you'll consider the following examples, example 1 and example 2, these examples are the ones that we can use the square root method as a process of finding zeros. Let us go over example number 1, and I want you to write your own steps so that it is more personalized and you can easily understand what is happening when you're solving quadratic functions using the square root method. So the first step is to always create an equation by setting your function to 0. So we have x squared minus 9 equals 0. Now, second step is to isolate your quadratic term. So we have minus 9, so we have to add 9 to both sides because we want to isolate x squared, and we want that to exist alone without any attachment, without any other terms in the left side of the equation. So this cancels, becomes 0. Now we have x squared equals 9. So from this, after isolating the quadratic term, we can now extract the square root of both sides. So we have extracting the square root of both sides will give you this. But take note, when you extract the square root of a number, like what we talked in the previous days, we're going to place plus or minus outside and then put a square root sign, which means there will be two answers coming out. So the square root of x squared is x, and this gives you equals plus or minus 3. Now, we have found that the zeros or the solutions to example number 1 are positive or negative 3. Now, let us go over example number 2 this time, and the same thing, make your own steps so that you can easily follow what's happening in the whole solution. So our first step is always to create an equation from our function by setting the function to 0. So you have 2x squared plus 20 equals 0. That's always the first step. Next is we're going to isolate the quadratic term. Let it stay in the left side of the equation. So the positive 20 should be removed by subtracting 20 to both sides to balance 20 here. Now this gives you a new equation, which is 2x squared. Okay, this is 0 equals negative 20. Okay, so we always want x squared to be staying at the left side without any coefficient, or it means that the biggest coefficient is 1. So we will divide both sides by 2 to reduce both sides of the equation. So 2 and 2 is 1. So what is left here, x is x squared equals negative 10. So once you have x squared and a specific value on the right side, we can now extract the square root of both sides. So take note, extracting the square root of a number, you need to normally put plus or minus sign before the square root sign. So in the side we have x, and in the side we have plus or minus. The square root of negative 10 is square root of 10, and since there's a negative value inside, it becomes imaginary. So again, there is no square root of 10, and 10 also has no factors that are perfect squares, so 10 will stay inside the square root sign. We don't normally accept answers directly taken out from the calculator, so it is good to have written our answer in this radical form. So we have x is equal to plus or minus the square root of 10i. Now we're going over example number 3, and it's the same question. You're asked to find the zeros of this quadratic function using the square root method. So first step is to always create an equation by setting the function to 0. So we have 4x squared minus 9 equals 0. Next step is to remove the constant from the left side of the equation, and that is done by simply adding 9 to both sides. So plus 9, okay. This is 0 now. What is left will be 4x squared equals 9. Now, if you know that 4 is a perfect square and we can extract the square root of the left side, we can proceed from that. But if you don't, you can normally go to what's normally being done with the previous examples by dividing both sides by 4 first. By 4, this is reduced. Okay, so what is left this time is x squared equals 9 over 4. So once you have x squared isolated and it's equated to a certain value, you can now extract the square root of both sides. So when we extract the square root of the right side, it will be plus or minus. So final answer is x equals plus or minus the square root of 9 is 3, the square root of 4 is 2, so the answer is plus or minus plus or minus 3 over 2. Okay, last example. Example number 4, x squared minus 24. So the same thing like what we did in the previous examples. Create your equation by setting your function to 0. So we have x squared plus 24 equals 0. Next, we are going to isolate x squared, so we have to add 24 to both sides, plus 24. This is cancelled to 0, so what's left is x squared equals 24. From this, we can now extract the square root of both sides, plus or minus square root of 24. So what's left on the left side this time is x equals plus or minus 24 can be broken down into a factor or factors that one is a perfect square, that is 4 times 6, which means that we can extract the square root of 4, we can put it outside. So our final answer is plus or minus 2 square root of 6, because 6 is not a perfect square, it will stay inside. So our final answer this time is x equals plus or minus 2 square root of 6. Okay, so if there are questions, prepare your questions for our synchronous class tomorrow before we will give you our formative test.